Stop thinking of eBPF as an observability tool. That's the gateway drug. The real story: eBPF is collapsing your entire infrastructure data plane into the kernel. Load balancing, security, traffic control, all running in the kernel itself. And it's already running at hyperscale. So what is eBPF really? It's a sandboxed, JAT-compiled runtime inside the Linux kernel. You write a small program, a few lines of C, and inject it into a specific hook. A hook is a point in the kernel where events happen: syscalls, network events, function entries. Before the program ever runs, the verifier checks it line by line. It's a static analyzer. It walks every execution path, rejects anything dangerous, loops, arbitrary pointer arithmetic, out-of-bounds memory access. If it passes, the JIT compiler translates the bytecode into native machine instructions. The result: a safe, fast program executing directly in the kernel's data path before user space ever touches a packet. No kernel module, no reboot, no risk. This is what makes eBPF revolutionary: kernel-level power without kernel-level danger. Now here's the architectural shift that matters. In a typical service mesh, every service runs an envoy sidecar in user space. Your packet goes from app to proxy, proxy to kernel, kernel to proxy, proxy to the next app. Every hop means context switches, buffer copies, iptables, NAT overhead. That's the proxy tax, and it multiplies across every request in your cluster. Cilium uses eBPF to replace envoy sidecars entirely, moving load balancing and service mesh logic into the kernel. The result: zero copy data paths. The packet stays in the kernel from source to destination. No user space detours, no copies. And it goes even deeper. XDP, eBPF's fast path, runs at the network driver level before the kernel stack even processes the packet. Meta's Cutran and Cloudflare use XDP for DDoS mitigation and load balancing, achieving orders of magnitude lower latency and CPU overhead compared to iptables or traditional user space proxies. They've proven it at hyperscale. But there's a catch. The verifier is brutal. It rejects loops, arbitrary pointer arithmetic, complex memory access. No loops allowed. Every program must be probably terminating. That's its superpower. It guarantees safety in a way kernel modules never can. But it also means your debugging tooling is still immature. BPF tool, tracefs, and kernel compatibility C, ORE and BTF is a real operational headache. So is eBPF a silver bullet? No. For simple static firewalls, just use iptables. But if you're building platform infrastructure, eBPF is the default future of the kernel. One runtime, 3 domains: networking with Cilium, security with Tetragon, observability with Pixie. It's not about visibility anymore. It's about rewriting the data plane itself. eBPF is collapsing the data plane into the kernel. The future of backend infrastructure runs in the kernel.